Now to prove the chain rule. Of course, we need to start off with a composite function, y equals f of g of x. And what we want to show, of course, is that the derivative of y with respect to x at some number a is f prime of g of a times g prime of a. To do this, I've graphed two functions here. I've graphed g of x, which I'm going to let g of x equal u, and I've graphed the composite function f of g of x. But let's start off with the g of x, this one right here. What I've done here is I've labeled a on the axis just arbitrarily, and I've gone up, and on the graph at the point a, g of a, I've made a secant line to some arbitrary point on the graph down the line. Obviously, you can see that the change in the vertical here is delta u, and the change in the horizontal is delta x. And if we want to talk about the slope of that secant line, of course, we just do the change in u over the change in x, and that is going to be approximately g prime of a. It's not g prime of a because g prime of a would be the slope of the tangent. But we're talking about the slope of the secant. So let's just say it's g prime of a plus some error. And now that's a true statement. And now with a little algebra, I'll just multiply through by delta x and isolate the delta u. So we've got g prime of a delta x plus epsilon 1 delta x. And there we have something that we're going to need to come back to in a minute. Now I want to do the same thing over here for the composite function. So, but instead of a, I've got g of a now, and I go up on the graph, and I make a secant line. Again, just like before, the secant line. There's my secant. And as before, I'm going to talk about the slope of that secant, which is delta y over delta u. And I'm going to say that that is equal to f prime of g of a. But not exactly. We got an error term. So now I'm going to multiply through by delta u, and I get delta y is equal to f prime g of a delta u plus epsilon 2 delta u. Okay, so now that's the second part. Now remember, what we're trying to do is we're trying to show that delta y over delta x as delta x goes to 0 is equal to supports the idea of the chain rule. Now, delta y over delta x as delta x goes to 0 is the derivative. So we want to show that it's equal to this. That's what we want to show. Well, first of all, I need to write down what delta y over delta x is. Now, first of all, we have delta x down here. And let's see what delta y is. Well, it's f prime of g of a. But instead of delta u, let me put what delta u is. Delta u is this thing. So here I go. I'm going to put that down. G prime of a delta x plus epsilon 1 delta x. Okay, there's delta u. And then plus epsilon 2. And once again, I put g prime of a delta x plus epsilon 1 delta x. Okay, so a lot of writing here. Now, you'll notice that I have a delta x that I can factor out of here and a delta x that I can factor out of here, and in fact out of the whole thing. So what I get then is I get delta y over delta x is equal to f prime of g of a times this thing, g prime of a plus epsilon 1, because the delta x is gone, plus epsilon 2 g prime of a plus epsilon 1. So what I've done is I've just taken the delta x's out, divided it out with the delta x on the bottom. Now, here's what we're going to do. We're going to say, well, what happens if delta x goes to 0 in this thing? Now, we know that this is the derivative. But if you think about it, as delta x goes to 0, these error terms right here, they're going to both go to 0 because that secant line becomes the tangent. And so that as the difference goes to 0, not only does dy, well, let's look back here. Change in u over the change in x, it goes to exactly this because this error term goes to 0 as delta x goes to 0. Well, if that's the case, then what we have is f prime of g of a times g prime of a. And that's it. That proves the chain rule. And at this point, you can just drop your marker and leave because you're done.